Okay students, so today our topic is chemical reactions of the ether. We will discuss about ether chemical properties. What do you mean by the ether? This ROR group. This is known as the ether. Ether is not so reactive, it is less reactive. It is less reactive. So it shows only some reactions and it shows the reactions in drastic conditions. Not in simple condition, it shows the reactions in drastic conditions only. So in first reaction, we will see reaction of ether with the hydrogen halide. We will see reaction of ether with the hydrogen halide. Students, in alcohol you have studied about that. If we do the reaction of alcohol with hydrogen halide, so nucleophilic substitution was taking place. What was happening? Elimination of water, and here alkyl halide was forming plus water. Here alcohols are more reactive as compared to ether. So these reactions take place very easily in simple conditions only. But if same reaction we want to do with ethers, so reaction cannot be take place in simple conditions. Why it is? Due to less reactivity of the ether. So when this reaction can take place, either we will take hydrogen halide in excess. We will take hydrogen halide in excess. We will take excess concentration of this. And we will take presence of high temperature. Means in drastic conditions, reaction can take place. So what will happen here? Here simply we can write this bond. Here bond between carbon and oxygen get cleave. This bond break. Bond between carbon and oxygen. And formation of, we will give hydrogen to this and halogen to this. So what will form here? Here alcohol plus alkyl halide will form. Further what will happen? Further what will happen here? Further this reaction can take place with the hydrogen halide and further they can form Rx plus water. So we can write both of these reactions in a single reaction also. How can we write? By combining these. Here ROR plus 1 unit of hydrogen halide plus 1. We will add reactant into reactant. So 2 units of the hydrogen halide. Here alcohol is forming and in this it is consuming. So we can cancel again. So here we will get 1 plus 1. 2 units of haloalkane plus water. Means we can write both of these reactions in a single reaction. This reaction take place after alcohol also. Why? Because we are using hydrogen halide in excess. We are taking this in excess. So it can react with the second molecule also. It is clear to you or not? What will be the reactivity order for the hydrogen halide? It will be the Hi will be more reactive, then HBr, HCl and HF. It is not reactive. It is very least reactive. Why it is more reactive? Due to the big size, due to the greater size of the, or we can say due to large size of iodine. It can lose H positive easily. It can lose H positive easily. Okay. So for hydrogen iodide, reactivity will be maximum. Clear to you or not? So this will be the reactivity order, and we will take hydrogen halide here in concentrated form, because in simple conditions reaction cannot be proceed beta. So we will take the hydrogen halide in concentrated form here. Especially we do the reaction with hydrogen iodide and hydrogen bromide, because after that reactivity order is going to decrease. So this is clear to you or not? Now we will see mechanism of this reaction. What will be the mechanism for this reaction? First of all, we have ether. You know very well, oxygen has 6 electrons in outermost shell. So 1 electron it consumed here, 1 here. So it has 2 lone pair. We were doing the reaction with hydrogen halide. Let us consider we were doing the reaction with hydrogen iodide. Here iodine is more reactive, so negative charge will attain on that. And hydrogen is less electronegative, so positive charge will attain on this. Clear or not? So here, it needs some electron. From where it can take electron? It will take electron from this oxygen. From this oxygen. This oxygen will give electron to this. Then what will happen? And this iodine will take its electron and it get removed. It get removed. So what will happen? RO, it is giving the electrons. So positive, and it is making bond with the with hydrogen also, and one bond with R also here. Okay. So students, we plus iodine, plus iodide ion removed. Now reaction will start because it is unstable. Why it is unstable? Because positive charge in on oxygen. So now SN2 mechanism will be followed by this. SN2 mechanism. What will happen? We have RO plus RH and iodide ion. This iodide ion will do attack from backside at this carbon. Why? Because this oxygen is more electronegative, so and positive charge is on it. So it will take electron from this carbon. So some deficiency of electron take place at this carbon. Clear or not? So from here, this iodine will support this one and it will take electron again. So finally, what will we get? We will get Ri plus alcohol. Plus alcohol. So in this way, we can get the product. Clear or not? So here backside attack is taking place and concentration of both H important here, concentration of iodide ion as well as for this. So these are the conditions of the SN2 mechanism. So it follow the SN2 mechanism. Further, it can take place with the same mechanism can be followed by alcohol. Okay, you are able to do or not? Okay, students. But student, let us consider if we have at place of this R, because this alkyl group may be any methyl, ethyl, propyl. If we have here CH3, but here C2H5, but here C2H5. If we have, so CH3 will come here because here we are doing protonation only, C2H5. Now it is the point, here we have CH3 and here C2H5. At which carbon? Because both are the carbon, this oxygen can take electron from this one also and from this one also. Okay, so it will take electron from which carbon? Because here SN2 mechanism is followed. So students, we will see where less steric hindrance is present. So this alkyl group is the bulky group. This alkyl group is the bulky group as compared to this methyl. Ethyl is bulky as compared to the methyl. So here less crowdness, less steric hindrance will take place at methyl. It is clear to you or not? So attack of iodide ion will take place at methyl, not at ethyl. If both are the symmetrical, both alkyl group are the same, so it can take electron from anyone. But here, because we are using the mechanism, we are following the mechanism SN2, so it will do the backside attack on that carbon which is less hindered. Clear to you or not? So here what will be the product we will get? We will get CH3I, methyl iodide plus ethanol. It is clear to you or not? Any doubt in this? Okay. But students, if you have anizole, what is formula of anizole? C6H5OCH3. If you want to do same reaction, so what will happen here? Iodine will attach to this, so methyl iodide, because it will attach to at the small group where less hindrance take place, less crowdness is here, and phenol will form. Students, in case of the alkyl ether, first of all, alkyl halide was producing plus alcohol. Further, this alcohol can react with 1 unit of hydrogen iodide or hydrogen halide, and further they can give us alkyl halide plus 1 molecule of water. But here, in case of anizole, this phenol cannot react further. Why? Due to the partially double bond character. I have already discussed in previous classes when we were studying the phenol. Here in resonating structures, partially double bond character is here. So it cannot undergo the nucleophilic substitution in simple conditions. Okay. So simply this reaction will not produce, not proceed further. Will not proceed further. Clear or not? Any doubt in this? Students, the mechanism which we have followed, this mechanism is followed only for the primary ethers and for secondary, because for these we can follow SN2, but if we want to make tertiary halide here, if we want to make tertiary halide, so how can we get, what will be the mechanism for this? How can we get, what will be the mechanism for this? Now I am going to discuss that. So you will take tertiary group OCS3. This type of the ether you will take. Then you will do reaction with the hydrogen halide. So what mechanism will be followed? Here this iodine is more negative, so negative charge will attain on this. And positive charge will attain on this. So who will support this hydrogen? Further, in same way, it will support this one. It will support. Okay. Then it get removed from here. So we will do same which we have done in previous mechanism. Here positive charge will attain on oxygen because it is giving electrons. Hydrogen will attach to this one, OCS3 plus I negative. Students, now changes will take place. Here you know very well, if this carbon gives electron to this oxygen, then it forms tertiary carbocation. And you know very well, tertiary carbocation is more stable carbocation. Okay. So because tertiary carbocation is more stable, so from here generation of tertiary carbocation take place easily in same step. And from here formation of alcohol take place. But this is the slow step. This is the slow step. So rate of reaction will depend on this step. And we have iodide also in solution. We have iodide also. So in next step, iodide will attach to this carbocation by electrostatic force of attraction, and this will be very fast step. This will be the very fast step. So finally we can get tertiary halide, tertiary alkyl halide. But student, here which mechanism is followed? Here rate of reaction is depending only on the concentration of this, and reaction is taking place in two steps. So it is following, and formation of carbocation is also taking place here. So if we want to prepare tertiary alkyl halide, then which mechanism we will follow? All these are the conditions for the SN1 mechanism. If we want to prepare primary halide and secondary halide, then we will follow the SN2 mechanism. But if we want to form tertiary halide, then we will follow the SN1 mechanism. Why it is from here? Because tertiary carbocation is more stable. So easily it can give electron to this one, and removal of alcohol take place and formation of carbocation take place. This mechanism is clear to you or not, beta? Any doubt in this? Yes. Okay, students. So this is enough for today. I hope it is clear to you. Any doubt? Okay, so thank you. Have a nice day.